Welcome to the next session, my dear friends. So in this session, in the previous session, we were discussing about the disposal of the solid waste. Up to pyrolysis we have discussed. We need to discuss composting and pulverization. Composting and pulverization. So what is meant by pulverization? What is meant by pulverization? See, pulverization is nothing but grinding. Pulverization is nothing but grinding. So whenever we put all the solid waste in a big grinders, and we grind it, okay, then what happens? So during this grinding, the complex molecules will become simple molecules, okay. So during this grinding process also, some kind of solid waste material will react with other solid waste material. So as they are becoming simple molecules, they will easily react, okay. So they will, during this pyrolysis itself, they will become stable to some extent. The organic matter or the solid waste will become stable to some extent. But this is not a complete process. Pulverization does not completely remove the solid waste organic matter. But after pulverization, either we need to do land forming or we need to do this kind of composting, trenches, keeping it inside the trench for a while, and also or else we can do simply land forming. That means dump this pulverized paste, that means this pulverized solid waste, on a land, spread it on the land. So these two things we need to do after pulverization. So by doing this pulverization, what we can achieve is we can do this process, we can get this process done little faster because we are exposed it completely. So it takes very less time, and also during this pulverization also some amount of solid waste is getting stabilized. So the rest of the organic matter will get stabilized very faster. That is the benefit of the pulverization, okay. So generally we don't use much this pulverization technique because it needs a lot of energy and all, grinding and all. It is not suitable for municipal solid waste, okay. So the last and very important method, that is composting. This composting, why it is very important is, this is eco-friendly. Composting is eco-friendly. See, composting is a kind of sanitary landfilling only, but we have just made it some technical, we have given some technical inputs into this. That is why we call this as composting. See here, composting is also similar to sanitary landfilling. We will dig a trench, we will dump all the organic matter, solid waste into it. But the difference between the sanitary landfill and composting is, in sanitary landfilling we don't do processing of the solid waste. Here processing of solid waste needs to be done, and we need to remove we need to remove the recyclable material and also non-biodegradable material such as plastic, rubber and all. We will remove that kind of non-biodegradable material out of the system first, out of the solid waste. And again we need to keep some kind of interest on carbon to nitrogen ratio in this, C/N ratio. So carbon to nitrogen ratio plays a very key role in composting. Generally, so what is the C and N ratio? So C means carbon, N is nitrogen. So generally whatever the organisms that are present, so this composting we generally treat it as aerobic only, but this can be done in anaerobic way also. So we treat it aerobic methodology only. So now during this aerobic methodology, first of all, here two kinds of aerobic bacteria will work. One is mesophilic bacteria and another one is this thermophilic bacteria will work. First, mesophilic bacteria will come and increase the temperature of the compost, and then this thermophilic bacteria will come and reduce it further. And also here we are using carbon and nitrogen, and here the bacteria uses 30 to 50 times faster. So the bacteria uses carbon 30 to 50 times faster than using nitrogen. So that means, so the bacteria consumes carbon 30 to 50 times faster than nitrogen. So that is why we need to keep more carbon and less nitrogen. So if you are keeping very high carbon, then what happens? For this reaction, both carbon and nitrogen both are required. When nitrogen is exhausted, when carbon content is very high, nitrogen will exhaust faster, so carbon will be left over in the system. So that means the organic matter is not completely decomposed. And if the carbon content is kept lower, nitrogen is more, carbon will first exhausted and nitrogen will left over. This nitrogen will react with the water, whatever the present, it will become ammonia, and this ammonia will again kill the bacteria present in the inside of the system. So that is why we need to, this C by N ratio indicates, this C by N ratio decides the complete removal of the organic matter. So that is why generally the C by N ratio we keep it approximately in between 30 to 50. So to keep it inside the 30 to 50, technical knowledge is needed. So we need to know what is the organic matter is coming. So what is the carbon content, carbonaceous demand is how much, nitrified demand is how much. So what is the ratio it is coming? If carbonaceous demand is coming more, then we need to add some kind of nitrified demand also parallelly, either artificially also if it is needed. So that is why generally we use night soil here. Night soil is nothing but human excreta. So the night soil also we use to, in order to manage this C by N ratio. Generally the effluents which are coming from the industrial origin, they will be having more amount of carbonaceous demand. So in order to fit that carbonaceous demand, to need to fit the nitrogen into it. I already told you in the nitrogenous cycle. So the excreta, human excreta is again nitrogenous cycle. In that nitrogen cycle, human excreta is also going there. So that is, human excreta contributes some nitrogen to it. So that is why, so we add some human excreta whenever it is required, when the carbonaceous demand is coming more. So we will add the nitrified demand to it in order to maintain this C by N ratio as 30 to 50. So and again, so this method, so in this method the end products, so because we are properly managing it, that is with the end products will have heavy nutrients which are useful for plant growth. So that is called manure. We call that as manure. So here it is a very eco-friendly method. It is a very eco-friendly method, can be done in aerobic way and anaerobic way. But the aerobic way, there is a small problem, that is we need to ensure the air flow to every point inside the composting. So in order to achieve that, we generally mix it up, whatever the pile, whatever the soil pile, so we need to mix it up. So mixing is little difficult in order to maintain aerobic conditions. Mixing frequently the compost is little difficult in a larger spectrum. So that is why what we generally do, there is another method also developed, anaerobic method. Aerobic method is also there, anaerobic method is also there. So there are two methods are proposed for composting. One is aerobic method, another one is anaerobic method. So aerobic method is indoor method. So the methods are, one is indoor method, and another one is Bangalore method. So indoor method is aerobic. Here we need to mix the pile. So we need to mix it from the top to bottom, bottom to top, like this frequently at regular time intervals. And in Bangalore method, no need of mixing. So what we do, we will dig a trench. We will dig a trench, and in this trench one layer of night soil, and one layer of this solid waste, one layer of solid waste. So night soil, solid, approximately I told you already 30 to 50 ratio by looking at the 30 to 50 ratio, and cover it up with good brick earth, good earth. Cover it up with good earth. Okay. So this way, this take little more time. It is anaerobic method. It takes little more time than aerobic method. But here, so no issues of mixing and all. So we can use, in some locations we use aerobic method. In some locations we use anaerobic method. Both methods are available, and this is the best method of solid waste disposing. This is the best method of solid waste disposing, very eco-friendly. And these days many rural areas and cities also, they are using this composting technique only in order to make it eco-friendly. Okay, these are the different systems. These are the different systems we are having for the disposal of the solid waste, This is all about the solid waste disposal. Now we are going to solve the previous year's GATE questions. Okay, so let us start the previous year GATE questions. Solid waste management. See, GATE 2006 2 marks. Question number 1. The first question. The municipal solid waste, the composition of certain municipal solid waste sample and specific weights of its various components are given below. The component and given, and the percentage by weight and specific weights are given. The specific weight of municipal solid waste sample is how much? Okay. So what is the given data? Component and its percentage by weight, and specific weight. In kg per meter cube. That is nothing but density. So food, first one is food. It is 50 and its specific weight is 300. And next is dirt and ash. Dirt and ash. Its percentage is 30 and the specific weight is 500. And third one is plastics. Proportion is 10 and specific weight is 65. Wood and yard waste. Wood and yard waste. Wood and yard waste, that is 10% and 125 is the specific weight. Then what is the specific weight of municipal solid waste? Specific weight of municipal solid waste, MSW. See, I told you already the formula 100 by, let us take it as rho of municipal solid waste is equal to percentage A by rho of A plus percentage B by rho of B plus percentage C by rho of C and so on. So percentage A is how much? 50. So what is the rho A? So 300. Percentage B 30. What is rho B? 500. Percentage C 10. What is rho C? That is 65. Percentage D, that is 10. What is rho D? 125. Which is equal to 100 by. If you solve this, we will get the answer. If we solve this, we will get the answer as is equal to 217, which is equal to 217 kg per meter cube. Kg per meter cube. Okay. That is the solution for the first question. Let us go into the second question. GATE 2007, 2 marks. So, second question, that is GATE 2007, 2 marks question. Let us read the question. 50 gram of CO2 and 25 gram of CH4 are produced from the decomposition of a municipal solid waste with a formula weight of 120. Okay. What is the average per capita greenhouse gases production in the city of 1 million people with a municipal solid waste production of rate of 500 ton per day? Okay. So here, what is the given data? 50 gram CO2, 50 gram CO2 plus 25 gram CH4 is produced. So these two are produced when we are decomposing an organic matter. Excuse me. Decomposing an organic matter which is having a molecular weight of 120 gram. So some organic matter which is having a formula weight of 120 gram. This organic matter, when we are decomposing this, we are getting this much of CO2 and this much of CH4. We don't need what kind of organic matter we are taking. So we are taking 120 gram of organic matter. Out of this organic matter, 25 gram of CH4 and 50 gram of CO2 is evolving during the decomposition process. That is the first statement they have given. What is the average per capita greenhouse gas produced? So what we need to find? Average per capita greenhouse gas produced. Average per capita greenhouse gas produced is equal to how much? So the capita is given, how many population? So the population is Population is 1 million. Population is 1 million. And gas and municipal solid waste. So the municipal solid waste production. Municipal solid waste production is 500 ton per day. So 500 ton per day. See, very simple question actually. For 120 gram municipal solid waste, so 50 plus 25, 75. This is greenhouse gas. CO2 and CH4 both are greenhouse gases. So now 75 gram is the greenhouse gas. Okay, 75 is greenhouse gas. Now, so this is 75 gram for 120 gram. I told you already the air pollutant just now during the incineration and pyrolysis process. So what I told, air pollutants will come out, and I also told you what are the different kinds of compounds that will come, because you need to know what are the greenhouse gases, because here the main thing is when you are doing the question, you know, many people know CO2 is a greenhouse gas, but many people may not be knowing CH4 is a greenhouse gas. I told you already just now during the discussion of pyrolysis. What I told, what are the gases that evolves? CH4 and CO2 are the gases which are air pollutants. So pollutants are nothing but greenhouse gases which increases the temperature. That is, those are called greenhouse gases. Okay, so CH4 and CO2 both are greenhouse gases. Anyways, we will discuss this part in air pollution part. There we will know what are the different kinds of greenhouse gases and all. Okay, now so 120 gram of municipal solid waste is evolving 75 gram of greenhouse gases. So 1 gram of municipal solid waste is evolving 750 by 120 greenhouse gas. Okay, now for 500 tons, here they are asking per capita. Per capita means per day, per population per day. How much, what are the units given? So a day only, they are asking for a day. So if 500 ton is coming for a day, for 500 ton, how much greenhouse gas will come? 75 by 120 into 500. Okay, so this is a proportion. This is again ton. This much of greenhouse gas will come. Now 75 by 120 into 500 ton means 500 into 10 to the power of 3. 1 ton is equal to 1000 kg, and each kg is nothing but, again, if you want it in gram, here the options if you see it is in gram. So kg is converted into gram, that is into 10 to the power of 3. This is a gram of greenhouse gas will come. But per capita they are asking. Per capita means by population. This is population. So what is the population given? So for getting the per capita demand, per capita evolution. Okay, per capita evolution. So this is the total evolution of the total population. If you divide it with the population, that is 1 million. 1 million, that is 10 to the power of 6. So 10 to the power of 6 persons are there. Then we will get the per capita evolution of the greenhouse gases. So this and this will get cancelled. So this is gram per day, because this is ton per day. Okay, this is gram per day. So if you solve this, we will get the answer. If you solve this, we will get the answer as 312.5 gram per day. 312. So again I am saying, please listen carefully. 120 grams of municipal solid waste is giving 75 gram of greenhouse gas. 1 gram will give 75 by 120 gram of greenhouse gas. That means 1 part of municipal solid waste is giving 75 by 120 parts of greenhouse gas. So if it is 500 ton per day, then 75 by 120 into 500 ton per day greenhouse gas will evolve. Okay, this is a total greenhouse gas that is evolving per day. This is the total in gram. If I want for one person, this is for total 1 million person. This is for one person, I need to divide it with the total person, that is 10 to the power of 6. Then I will get the per capita demand. Actually, this should be 312.5 gram per person per day. But anyways, he told it is a per capita demand. So indirectly it is there inside the unit itself. Okay. That is why it is given like gram per day. So third question. GATE 2008 1 mark question. Very simple question. Two biodegradable components of municipal solid waste are biodegradable. So plastic is non-biodegradable, glass is non-biodegradable. Option A, plastic is non-biodegradable. Option B, glass is also non-biodegradable. Cardboard, wood, they are all non-biodegradable. Leather, tin, these are also non-biodegradable. So biodegradable are food waste and garden trimmings. These are biodegradable, which are of plant origin. Okay, they are biodegradable. So food waste and garden trimmings are the answer. Food waste and garden trimmings. So cardboard, wood, they are all inorganic matter. They are non-biodegradable. Plastics, though carbon matter, but they are non-biodegradable. Okay, so only food waste and garden trimmings are biodegradable. Next, 2010 GATE. 2010. Question number 4. See here, a coastal city produces municipal solid waste with high moisture content, high organic material, low calorific value, low inorganic material. The most effective and sustainable option of municipal solid waste management in that city. See the term here. See, first of all, moisture content is more, organic content is more. So no need of separation. Organic content, if it is more, no need of separation. So we can directly dump it. Okay. Low calorific value means incinerator is not useful. Okay. The most effective and sustainable method. Sustainable means eco-friendly. That is nothing but composting. See here an option to dump in sea. See, that is also a disposal method. Actually, we can also dump because how we dispose the sewage effluent directly onto a water body. In the same manner, we also dispose the solid waste onto a water body. Generally, we choose sea for that. These days, you might know many countries, their waste, whatever the waste it may be, hazardous, non-hazardous, they will bring to the border waters. That means border water will be there, that is which is making boundary with two different countries. So there they will bring their ships and they will dump all the waste and go, so that their shore will not get polluted, the other shore may get polluted. So these some countries will give money to the poor countries. Some rich countries will give money to the poor countries, so that they will accept the waste of the rich country. They will dispose that waste on the sea of the poor country. So they accept it because they need money. So these days this is also happens. So the disposal of solid waste on sea is also very the method which is prominently used. Okay, if the quantum of solid waste is very high. So likewise, the solid waste can be disposed. So solid waste can also be disposed by dumping into the sea. That is also an option. So but eco-friendly and more sustainable method is composting. Next is question number 5. GATE 2015, 2 marks from set 2. Question number 5. So a landfill is to be designed to serve a population of 2 lakh for a period of 25 years. The solid waste generated is 2 kg per person per day. The density of uncompacted solid waste is 100 kg per meter cube and a compaction ratio of 4 is suggested. The ratio of compacted fill, that is solid waste plus cover, to compacted solid waste is 1.5. The landfill volume in million meter cube required is how much? Very nice question. So here, what is the given data? What is the given data? So this is nothing but design of sanitary landfill. So what is the given data? That is population is given. So population, 2 lakh population is there. Okay, 2 lakh population is there. And we are designing the landfill for a period of 25 years. Design period is 25 years. 25 years. So solid waste generation, two kg per day per person. So using these 3 data, we can find what is the total amount of solid waste that will come for the 25 years. So what is the total amount of solid waste that will come for the 25 years? We will understand from this value. Okay. Now, the density of the uncompacted solid waste. Density of uncompacted solid waste it is, let us take this as rho SW, so 100 kg per meter cube, 100 kg per meter cube, and a compaction ratio is 4. Compaction ratio is 4. The ratio of compacted fill, so the ratio of compacted fill, that is compacted fill contains solid waste plus cover by compacted solid waste. That is 1.5. That is 1.5. The landfill volume, so the compaction fill and compaction factor. So what he is asking now? The landfill volume. He is asking the landfill volume. In million meter cube. In million meter cube required is how much? So here just first analyze it, what he is asking exactly. So the landfill volume needed for this solid waste. Okay. So here first of all, what is the total waste that is going to get generated for 25 years? So let us first understand that. So what is the total waste? Total waste generated for 25 years. Okay. Excuse me. Total waste generated for 25 years. So per day it is 2 kg per day per person. So how many days are there in 25 years? 25 into 365 days. And how many persons are there? How many persons are there? 2 lakh persons are there. So this is the total waste in kg. This is the total waste that is developed, that is generated by this community. So which is equal to how much? This is equal to 3. This is equal to 912. 365 into 10 to the power of. So this is 25 into 2. 50 into 2, again 1000. So this is 365 into 10 to the power of 7 kg. So this is the total solid waste that is generated by this community for 25 years. Generally sanitary landfilling means what I told you. We will bring the solid waste, we will dump in the trench. Okay. There we will compact it. So volume of the uncompacted and volume of the compacted will be different, and we compact it. After compaction we cover it with we will cover it with a good earth, and we will leave it for some period of time. After that it will settle down. After digestion is completed, it will settle down by 2/3 of its volume. That means only 1/3 will be left over. So likewise we have discussed. So the same thing, we just analyzing it in a proper manner, step by step. So first of all, so for this trench we need to know what is the total solid waste which we are bringing and dumping into this sanitary landfill. That is the first and foremost thing we have completed. And now, so what is the volume of it? So this is weight of it. I told you this is also. So we need to find the volume first. In order to know the volume of the sanitary landfill needed, first of all we need to know what is the volume that is coming into the trench. So that is the volume of uncompacted solid waste is equal to, so weight by uncompacted density, that is 365 into 10 to the power of 7 kg by 10 to the power of 100 kg per meter cube. So this is the volume of uncompacted, solid waste, which is equal to 365 into 10 to the power of 5 meter cube. And here they have given a compaction ratio. So this is compaction ratio. Now the compaction ratio was given as 4. That means what is this 4? So when we are sending, this is nothing but the volume of uncompacted by volume of compacted solid waste. So this compaction factor is nothing but volume of uncompacted solid waste by volume of compacted solid waste. This is 4. This was given as 4. So volume of compacted solid waste is equal to, so volume of uncompacted solid waste by 4. It is nothing but 365 into 10 to the power of 5 meter cube by 4. So this is the volume of the uncompacted solid waste, which is coming around 9125,000 meter cube. 9125. So this is the uncompacted volume of solid waste, not of the solid waste plus cover. See here, compacted fill, that means compacted fill means solid waste plus cover. It is, the ratio is, it is coming 1.5. So here we are having the volume of the compacted solid waste. We are having the volume of the compacted solid waste. So volume of the cover. So if you use this equation, let us take this as V1. Okay, let us take this as or else V. So which is nothing but V1 plus V2. This is V, which is equal to V1 plus V2. So V by V1 is equal to 1.5. Okay, so V is nothing but V1 plus V2 is equal to 1.5 V1. So V2 is equal to 1.5 V1 minus V1. So that means 1.5 minus 1 into V1. Are you getting the point? So V1 is solid waste volume, compacted volume of solid waste. V2 is the compacted volume of the cover, and this is again V1, compacted volume of solid waste. So V1 plus V2, I have taken it as V. So V by V1 is equal to 1.5. Okay, so V is nothing but V1 plus V2. V is nothing but V1 plus V2 is equal to, this V1 will go there, 1.5 V1. That means V2 is equal to, this V1 will go that side. So if you take V1 as common, V2 is equal to 1.5 minus 1 into V1. So V2 also we got now. So we know V1. So that means V2 is equal to 0.5, this by 2. This is V2, this is V1 and this is V2. So both we got, V1 and V2. So this is the total volume required, V1 plus V2. So total volume of landfill is nothing but V1 plus V2. So V1 is the volume of the compacted solid waste and V2 is the volume of compacted cover. So this is the total volume of the landfill, which is equal to 9125,000 into 1 plus 1 by 2, that is 1.5 again. So that is nothing but V is nothing but 1.5 V1. From here also we can directly find. He is asking V. So V is equal to 1.5 V1. So V1 if you know. So from here directly, no need of doing all this thing. Without doing this also, we can find directly from here. V is equal to 1.5 V1. So V1 you have. So V is nothing but 1.5 times of 9125,000, which is equal to 136875. So 136875 meter cube. 136875 meter cube. Million meter cube he is asking. Million means, so 336, put it here, 13.69 approximately. 13.69 is the answer. 13.69 million meter cube volume is needed for the sanitary landfill. So this is a very nice question. So very simple question also. If you know a little what is compaction ratio, sometimes something you need to assume, you need to think out of the box. Every time you don't get the questions which we have discussed in our class. Sometimes you need to think little out of the box. So compaction ratio means it is 4. So it is greater than 1. That means what? It should be ratio of uncompacted to the compacted. Obviously uncompacted volume will be more, compacted volume will be less. So which we need to think little out of the box like that. Okay. So this is the solution of this question. So we will discuss the rest of the questions in the next session. Thank you so much.